Now we can move forward and we can start setting up the .NET simulation. And I'll get rid of this assemble node and I will drop down an exploded view. And let's preview this. So we want to take these pieces that we have and we want to create low resolution proxies of all of these pieces, which we can use to speed up our simulation. So from this fracture main, I will drop down a convex decomposition node. And for this node, all of these properties should be fine. So if I preview this now and give it a second to cook, this should be a fairly fast operation. Alright, so if I preview these pieces now with my exploded view, we get a very rough approximation of how our pieces look. And we can see that we are working with very low geometry count, and these are all convex pieces, which will greatly improve the speed of our simulation. So we will run the simulation on these low quality proxy pieces, and after we cache the result of the simulation, we will then swap them back to our original high quality fracture. And from here I will drop down an assemble node, so we have to make sure that these are packed primitives. So set the assemble node, let's uncheck create name attribute because we already have the name, and create packed primitives. So we can see that we have 9500 packed primitive. Let's also drop down a file cache and save this version as well. Disable version and type dependent, select the folder, and I will rename this to fracture main packed and save to disk. Drop down another null here and rename this to fracture main packed. So let's start setting up our DOM network. Let's drop down a .NET and I will copy this node, Control C, step inside the .NET, and I will drop a RBD packed object and use the subpath to point to my fractured pieces. Okay, so make sure that you have the low resolution pieces in this packed object node. So from here we want to drop this into a rigid body solver. Let's plug this into our output. And for now let's just add a gravity because we will be needing gravity, of course. And we can plug this here after the rigid body solver. And if I preview the output and press play, these pieces should now be falling down. Okay, so it's pretty slow, but it's not that bad. So they are slowly moving down. Let's go back up a level. And maybe I want to further optimize some of the pieces a little bit and also get rid of the very small pieces that also have a surface primitive. So let's go back here to where we created our first split that determines which piece is a surface piece or not. And from this stream over here, let's also maybe call some of the very tiny pieces. So I will just grab these two nodes, the measure and the split node, and I will paste them over here in our main stream as well. And let's maybe preview the split node as well. And we can see that if I leave the split node by the default, this threshold value is a bit too high, and we see that we are going to be missing some big chunks of our original terrain, and this will really alter the look of our original surface a little bit too much. But if I were to set this threshold value to a very low value, so maybe 0.02, we can see that we largely maintain the look of our terrain, and maybe I can go even further to 0.01. So we still retain the shape roughly of our original terrain, but we are still culling a lot of pieces. So if I go back here to my merge, if we pack the pieces, so if I drop down an assemble node and I set this to create packed primitives, we were working with 9500 pieces, and if I create packed primitives, now we only have 6300 packed primitives. So we will improve the time of our simulation even further. Now you can see that there are these small gaps in our terrain surface, and if you're working on a professional shot and the director wants the terrain to remain intact, then you probably shouldn't do this second culling over here with the surface pieces, but for the sake of this tutorial and keeping things a little bit lighter and faster, I will also cull some of these surface pieces as well. So maybe I will go to my first file cache here and recache my original fracture, so this fracture main. Okay, and now I also have to recache my file after we turn these into our proxy pieces. So save to disk as well for my second cache over here. Okay, so we can see that from 9,500 primitives, we will go to 6,300. So this will just speed things up a little bit. So back in our .NET, we can check that this is still working, and if I press play, it should run a little bit faster, and we can see that the pieces are falling. And so from here we can move forward.